So now for some practice questions. Um, these are like ones you might see on IB test. So the first one is state two differences between the particle model of a solid and a gas. So what's a difference? Two differences between solids and gases using the particle model we've been talking about. Second question is multi-part. It says name the following changes of state and explain them in terms of kinetic molecular theory, right? Kinetic is motion. This is the theory we've been talking about. So name what this change is and then give an explanation for why it's happening using this framework. I would suggest you pause here and take a moment, and then I will go through the answers with you. So, the first one, solids, particles in fixed position, whereas gas, they are moving freely, right? Another thing you could have mentioned is particles are vibrating in solids, whereas they're moving at high speeds in gases, right? Number two, water to ice is called freezing, and there is a decrease in the kinetic energy, right? And the intermolecular forces are able to hold the molecules in fixed positions. So you decrease the kinetic energy until those intermolecular interparticle forces are strong enough to hold the particles in place. B, water vapor to ice. This is called deposition. This one might have been a little bit tougher to explain, but what's happening is we have a rapid decrease in kinetic energy and the intermolecular forces are able to hold those particles in fixed positions. And deposition and sublimation have special conditions. And you're going to read about those after we get done with this slideshow. Number C is water to water vapor. This is vaporization, and we're increasing kinetic energy, and the molecules completely overcome and break those intermolecular forces. And then this last one, ice to water, is melting, increasing kinetic energy, and the molecules partially overcome those intermolecular interparticle forces. Here's another one. Label each part of the cooling curve for water. So we did the heating curve. Now label each part and then explain what's happening. This would be in terms of the kinetic molecular theory. So kind of like you were doing in that last thing. So this first part's a gas, right? It's a gas cooling. The particles in the gas are losing kinetic energy as the heat's transferred to surroundings. Then we get to condensation, right? Gas is becoming a liquid. And the temperature stays constant because the heat is released within the substance as intermolecular forces partially reform. Then we have liquid, right? It is getting cooled down, so its particles are losing kinetic energy. We get to freezing. The temperature stays constant because the heat is released within the substance as the IMFs fully form. And then finally, we have a solid where the intermolecular forces, the interparticle forces, are at their strongest and are holding them in place. Here's a new diagram. This one is a pressure versus temperature. And this can be really helpful in identifying certain things. And I want you to think about how does this phase diagram explain the decreasing boiling points at higher water. So if you take water up to a mountain, it will boil at lower temperatures. This fun, nifty thing. Why does that happen? What is true about higher altitudes and pressure and temperature? Look at this phase diagram. And then number 2 is T, right here, is the triple point of water. There's a special point on these graphs. Can you suggest which state of matter is present at this point? So think about those. Take a second, write down your answers. Okay, number 1, the temperature required to convert liquid water into water vapor, right, so the boiling point, decreases as the pressure decreases. So we can see that here. The temperature at which we need to boil water, which is changing from liquid into vapor, decreases as pressure decreases. As pressure gets lower, the temperature also gets lower, right? And at high altitudes, there's less pressure. There's less gas pushing down on you. So you have a lower boiling point. At T, all three states of matter exist. So if you ever are at the temperature and pressure triple point, you get all three states of matter at once. It's a really weird point. But we can also see all the phase transitions on this graph. So we have liquid to gas, right? Or gas to liquid, vaporization and condensation, solid to liquid or liquid to solid, freezing and boiling, freezing and melting. And then we have solid to gas, which is condensation, or sublimation and deposition. Here is another interesting question. And this is a cooling curve for an alloy. An alloy is a mixture, we've learned about those, of two or more metals. So like copper and iron could be an alloy, right? Why do we not see a plateau at the freezing point? We have a freezing range instead. So this happens because we have a mixture, right? We have two or more components, and each component begins to freeze at different temperatures. So our alloy, our mixture, will have a freezing range instead of a freezing point. So those are all my conceptual chemistry questions, but this is more theory of knowledge stuff, which you do also need to know for the IB exam. And it's really good and helpful to think about this stuff as well. So I am going to ask you these questions. And really, I want you to just think about them. And maybe we'll talk about them, sorry, when I get there. But these are just for you to think about right now. So, in what sense are visual representations in science helpful? We had a bunch of those today, right? We had graphs, we had graphics, we even had animations. What might some of their limitations be? Right, so graphs can describe some things very well and other things not so well. List visual representations that you have seen in other subjects. That could be biology, be math, that could be history, that could be anything. Do the same strengths and limitations apply? So I'd like you to answer all of these. Even if you're just thinking about them, that's fine, but I do want you to think and answer them, because this will help us down the road if we're thinking about the strengths and weaknesses of our visual representations and our models and the things we're using to communicate with, right? So take a second to do that, and then I'm going to talk about what you're going to do today for your work. You're going to work on learning about sublimation, which is one of those weird transitions, right? Happens between here. I can kind of go back real quick. Really far back. So if we're talking like right here, right? So sublimation is when you go from a solid to a gas. Sublimate. This is deposition, right? Sublimation can be used for a lot of things, a lot of interesting things. Medicine, for separating things. It even gets used in like cosmetics, and you can make materials and print things on materials with it. So I want you to read this article that I have on your assignment. It's actually just on the assignment. It talks about sublimation and then some of the uses that we, as human beings, use it for. And then I want you to research one of those things. So it could be any of the options. Like for example, you could research the medical applications. Just use Google, use the internet. And then you're going to answer a couple questions at the end of the assignment. based on your research that you did. So pick whichever thing is most interesting to you. All right, that's all I got for you today.